Tonight, when you look up at the night sky, you are looking at an illusion. We are taught from childhood that light is the ultimate cosmic speed demon. It is the fastest thing that can possibly exist in our universe. Nothing beats it. It moves so quickly that to our human senses, it doesn't even seem to travel at all. It is just here. If you shine a flashlight at a wall across the room, it doesn't take time to get there. The moment you press the button, the wall is illuminated. This immediate, instantaneous nature of light is wired into our biology. We evolved on a small, dense planet where distances are trivial. For our daily survival, light is effectively magic. It exists everywhere, all at once, the very instant it is created. We built our entire understanding of reality around this assumption of absolute instant, and for a long time, the smartest minds on Earth agreed. Aristotle believed light was instantaneous, an omnipresent force that didn't travel but simply existed. It wasn't until the late 17th century that an astronomer named Ole Rachmer noticed something strange about the moons of Jupiter, realizing that light actually takes time to move through space. When scientists finally measured that speed, the numbers were staggering: 300,000 kilometers per second. 186,000 miles per second. That is a number so large that our brains simply refuse to process it. It becomes an abstract concept, a placeholder for infinity. We hear that number and we think, yes, light is infinitely fast. But it isn't. To understand just how deceptive this illusion is, we have to start small. We have to look at our own world. If you were to fire a beam of light perfectly around the equator of the Earth, it would circle the entire globe 7.5 times in a single second. It happens so fast that if you blinked, you would miss those 7.5 laps entirely. On Earth, light is a ghost. It is a god. It moves across our continents and oceans as if space itself does not exist. But the moment we take our first step away from this blue marble, the illusion begins to fracture. Consider the moon. It is our closest celestial neighbor, a mere stone's throw away in the cosmic backyard. When Apollo astronauts stood on the dusty lunar surface and spoke to Mission Control in Houston, there was a strange, awkward pause in the conversation. A delay. It wasn't because of faulty radio equipment. It was because radio waves are made of light and the moon is far enough away that light can no longer hide its own travel time. A beam of light leaving the Earth takes roughly 1.3 seconds to reach the moon. That sounds brief. 1.3 seconds is barely a breath. But it means that when you look at the moon tonight, you are not seeing the moon as it exists right now. You are seeing the moon as it was 1.3 seconds ago. You are looking a moment into the past. The pristine, instantaneous universe you thought you lived in has already started to crack. And as we look further, that crack becomes a chasm. Let's push out to the sun, the anchor of our solar system, the source of all life on Earth. The sun is 93 million miles away. At this scale, the 7.5 laps around the Earth mean absolutely nothing. Light can no longer cross this distance in a heartbeat. It has to run. It has to grind through the empty void. A photon born in the heart of the sun escapes into the vacuum of space and begins its journey toward Earth. It travels at that mind-boggling speed of 300,000 kilometers per second. Yet it takes 8 minutes and 20 seconds to reach us. Think about what that actually means. If the sun were to suddenly vanish from existence right now, we would have no idea. The sky would stay bright, the grass would still photosynthesize. The Earth would continue to bask in its warmth. For 8 minutes and 20 seconds, we would live in a world illuminated by a ghost. We would be completely oblivious to the cosmic catastrophe that had already occurred, because the news of the sun's death is carried by a messenger that is simply too slow to deliver it on time. Suddenly, light doesn't feel like a god anymore. It feels like a commuter sitting in traffic trying to cross a bridge that is far too long. And our solar system is practically empty space. As we push out past the sun toward the outer planets, the traffic jam gets worse. If you were to sit on the surface of Mars, waiting for a text message from Earth, you would be waiting anywhere from 3 to 22 minutes for the signal to arrive, depending on where the planets are in their orbits. A real-time conversation with a Martian colonist is a physical impossibility. The physics of our universe forbid it, not because our technology is weak, but because light is too sluggish. By the time we reach Jupiter, light takes over 40 minutes to make the trip. By Saturn, it is over an hour. If you were to travel to Pluto, at the icy dark edge of our immediate neighborhood, and turn back to look at the sun, you would be seeing sunlight that left its source 5.5 hours ago. The central star of our system, the grand furnace of our world, is reduced to a dim point of light, whose morning news arrives late in the afternoon. At this point, a subtle shift begins to happen in your mind. You started this journey thinking about how incredibly fast light is, but as you watch it crawl across the solar system, taking hours just to leave our immediate family of planets, you realize something else. Light hasn't changed its speed. It is still moving at 300,000 kilometers per second. It is still sprinting as fast as the laws of physics allow. So why does it feel so slow? It feels slow because the stage it is running on has grown. The solar system is vast, but in the grand scheme of things, it is an invisible speck of dust. To leave the solar system is to enter a deep, terrifying wilderness. The distance between our sun and the very nearest star system, Alpha Centauri, is so immense that measuring it in miles or kilometers becomes completely useless. We have to invent a new unit of measurement based on the distance light can travel in an entire year. A light year, one single light year, is nearly 6 trillion miles. Alpha Centauri is 4.3 light-years away. If you were to look at Alpha Centauri tonight through a telescope, you would be seeing light that began its journey more than 4 years ago. That light left its star while humanity was navigating events that now feel like distant memories. It spent 4 long years coasting through an absolute freezing void, seeing nothing, touching nothing, moving at top speed every single second, just to finally hit your eye tonight. If light were an athlete running a marathon across the interstellar neighborhood, it would look like it is moving in slow motion, but we are still just in our local neighborhood. If we zoom out further, out of our local cluster of stars and look at the broader structure we call home, the Milky Way galaxy, the scale becomes genuinely horrifying. The Milky Way is a majestic, swirling disk of over 100 billion stars. To cross this disk from one side to the other, a beam of light has to travel for 100,000 years. Imagine a photon emitted by a star on the far edge of the galaxy. It begins its journey across the cosmic ocean. While that photon is mid-flight, Neanderthals are walking the Earth. Human civilization hasn't even crossed its mind. The photon keeps traveling. It crosses tens of thousands of light-years of empty space. While it is flying, humans discover agriculture. We build the pyramids. We invent the printing press. We launch satellites into orbit. Empires rise, conquer the known world, and crumble into dust. Generations of humans live, love, fight, and die. And all the while, that single beam of light is still on its way, tirelessly crossing the midsection of our galaxy, struggling to reach us. When you look at the stars in the night sky, you are not looking at the universe as it is. You are looking at a history book. You are looking at a graveyard. Some of the stars you see in the sky tonight might not even exist anymore. They could have exploded thousands of years ago, but the light carrying the news of their destruction is still traveling through the dark, dragging its feet across the immense expanse of the galaxy. At this scale, the word speed loses all meaning. Light is no longer a bullet, it is a snail. It is a trickle of water trying to fill an ocean. And yet, the Milky Way is just one galaxy. If we look past our galaxy, we see our nearest major neighbor, the Andromeda galaxy. It is a massive spiral of stars visible to the naked eye under a very dark sky. It looks like a faint, blurry smudge of light. That smudge of light took 2.5 million years to reach your eyes. The light from Andromeda that you can see tonight left its home stars before modern humans even walked the Earth. It left when our ancestors were hominids with brains the size of an orange, chipping away at stones to make primitive tools. That light has been traveling through the intergalactic void for 2.5 million years, moving at the absolute speed limit of reality, just to cross the gap between our two homes. If you were to watch a movie of the universe played at the speed of light, it would be agonizingly slow. You would sit in a dark theater for millions of years just waiting for a single frame to change. And beyond Andromeda lie billions of other galaxies. The observable universe stretches out for 46 billion light-years in every direction. If a beam of light were to start at the edge of the observable universe at the moment of the Big Bang, 14 billion years ago, and run continuously without ever stopping, it still wouldn't have reached us today. Space itself is expanding faster than the light can travel to catch up. There are parts of the universe whose light will never reach us, no matter how long we wait. They are permanently cut off from us, lost in a distance so profound that even the fastest thing in existence cannot bridge the gap. This is the moment where the perspective fully shifts. We started with a simple premise. We wanted to look at how slow light is. We wanted to break down the illusion of its instantaneous nature and show that, when tested against the cosmos, light crawls. But as you sit with this realization, you begin to see the true nature of the trick. Light didn't slow down. 300,000 kilometers per second is still an incomprehensible, terrifying speed. If you could move that fast, you could travel around the entire world before you finished reading this sentence. Light is not slow. The universe is just big. The true revelation of the slow speed of light is not a statement about physics or photons. It is a statement about the unimaginable, crushing scale of the reality we inhabit. Light feels slow only because we are trying to measure an ocean with an eyedropper. The slowness of light is a cosmic ruler, a tool that forces us to see the true depth of the void. We live our lives on a tiny island of instantness. We are trapped in a brief, beautiful bubble where our eyes see things the moment they happen, where our world feels compact and connected. We built our sense of importance on this illusion. We feel big because our sight fills our world instantly. But the moment we look up, the bubble pops. The universe does not operate on our schedule. It operates on a scale where time and space are melted together, where to look across distance is to look back through time. The cosmos is so vast that it isolates everything within it. Every star system, every galaxy is an island surrounded by millions of years of silence. We are not living in a universe of immediate connection. We are living in a universe of echoes. When you look out into the night sky, you are listening to the faint, delayed whispers of a cosmos that moved on long ago. You are watching a delayed broadcast of a reality that is too big to be seen all at once. The slowness of light is the universe's way of keeping us humble, a constant, silent reminder that no matter how fast we think we are small creatures standing on a small rock, looking out at an ocean that is far too wide to ever fully cross.